In this presentation, we will learn about TSN IP cores from CAST. CAST develops, sells, and supports digital silicon IP cores for ASICs and FPGAs. CAST was founded in 1993 and has always focused on reusable IP cores. IP from CAST ranges from leading-edge technology through traditional and standards-based functions. Our IP is available in synthesizable RTL for ASICs or netlists targeting popular FPGAs and structured ASICs. Our quality standards and business practices refined and evolved over the 3 decades of our operation. We have helped thousands of companies worldwide gain a competitive edge, and they have built our IP into billions of shipping product units. 1/3 of our sales are repeat customers, and we are a privately held company without external dependencies. Our vast range of cores include processors, peripherals, interfaces such as CAN, LIN, CENT, TSN, and IP protocol stacks, along with compression and security cores. Today's presentation will give an overview of our TSN line of cores. TSN stands for Time-Sensitive Networking, an IEEE 802.1 AS standard. CAST offers 3 different TSN IP cores: an endpoint, a 2-port switched endpoint, and a 3 to 24-port switch. The cores were developed by Fraunhofer IPMS, our partner since 2002, and is a member of the IEEE 802.1 AS Standardization Committee. Using CAST's TSN cores, any kind of time-synchronous network can be built. It's important to note that any of our TSN cores can be a clock grandmaster and support most of the TSN protocols. Here is a list of all supported TSN protocols. We support most common media-independent interfaces to interface with a PHY. The core also includes a low-latency MAC, capable of 10 base T1S, 100 base T, 1000 base T, and 10 gigabit interfaces. The basic core package also includes 802.1 ASPTP stack, FreeRTOS hardware abstraction layer, and FreeRTOS command line interface. CAST's TSN EP is an endpoint controller. It features one external Ethernet port and is suitable for star topology networks. It offers a latency of less than 100 nanoseconds, 4K to 8K, lookup tables, TSN timing synchronization, and full traffic shaping and filtering capabilities. It can be a clock grandmaster, and its system interface is AXI-Stream, which can be converted to a memory-mapped interface with an optional AXI-4 DMA core. CAST's TSN SE is a 2-port switch. It features 2 external Layer 2 switched Ethernet ports and 1 internal, and is suitable for daisy-chained or ring networks. Its cut-through switching latency is less than 1 microsecond port-to-port. It also offers such advanced features as a configurable VLAN PCP to TSN queue mapping, flexible VLAN and MAC forwarding and filtering, dynamic and static MAC lookup tables, untagged port support, and automatic aging table. Other TSN features include timing synchronization, traffic shaping, redundancy, and filtering. Similar to the TSN EP, the switched endpoint system interface is an AXI-Stream, which can be converted to a memory-mapped interface with an optional AXI-4 DMA core. CAST's TSN SW is an Ethernet switch. It features 3 to 24 external, Layer 2 switched Ethernet ports, and 1 internal. Its cut-through switching latency is less than 1 microsecond port-to-port. It offers the same advanced features as the switched endpoint. TSN-SW's system interface is AXI-Stream, which can be converted to a memory-mapped interface with an optional AXI-4 DMA core. Here is an example of one of the TSN's features: 802.1 CB. It replicates frames at source and reassembles them at the destination. The replicated frames are sent through two different links or paths. At the destination, if some frames are missing from one path, they can be reconstituted using their copies from the second path. The end result is a redundant connection, less sensitive to link failures. CAST's TSN SE and TSN SW cores offer this optional feature. We also offer a MACsec core, which encrypts the data at layer 2 level. This allows secure connections between two Ethernet peripherals. Our TSN cores can all be fitted with the MACsec core, which also features an AXI4 stream interface. Here is a more detailed block diagram of TSN to MACsec to AXI4 DMA interconnection. A packet arrives from a PHY over a media-independent interface. It goes through the TSN IP low-latency MAC. The MAC stamps the packet with receive timestamp and sends it to the optional MACsec module for decryption. Once decrypted, the AXI4 DMA places this packet in memory and signals the CPU that a new packet is available. The transmit path is the reversal of the receive path. All three cores, TSN, MACsec, and AXI4 DMA, are controlled over the APB bus. Streaming data is passed from one core to another over AXI4 stream interface. Let's look at some of the applications of CAST's TSN cores. One of the common applications of TSN is in automotive sector. In particular, the zonal architecture is well suited for a synchronous Ethernet network. A vehicle is split into zones, usually 4. Each zone is responsible for its own sensors and controllers. It has the capacity for localized control and decision-making, offloading the main ECM. This also reduces the amount of cables required to be passed in a vehicle. CAST also offers other automotive cores, such as CAN, LIN, CENT, PSI-5, and SAFE SPI. For industrial applications, TSN cores are used to simplify the interfacing and data transfer between various industrial protocols in the same cable. Each protocol's data is encapsulated into Ethernet frames and sent over the network. Using TSN, the network nodes are synchronized, which is important for time-critical control and automation systems. CAST offers reference designs, which are fully working implementations of our cores on various FPGA families. These reference designs allow testing of TSN technology, accelerate the design time, and assist during hardware development. Why choose TSN cores from CAST? Support and customer service are our top priority, where we answer most questions within 24 hours, as we have direct access to engineers who designed our cores. Our TSN cores are accurate with nanosecond-level jitter and offer robust timing synchronization. We offer ultra-low latency and have an extensive IEEE 8021AS related standards offering. All this in a small silicon footprint. Our cores were developed with ease of integration in mind. They use standardized AXI stream interfaces and come with hardware abstraction layer for Linux drivers and FreeRTOS drivers with easy-to-use API. These cores are also lint-clean and technology-independent, able to be ported to any FPGA or ASIC with sufficient resources. Our TSN cores support 10, 100, 1000 megabits per second, and 2.5, and 10 gigabits per second. We also offer flexible licensing options. We thank you for listening. If you have any questions, please don't hesitate to write to sales@castinc.com. We will be more than happy to work on your project together.